tan theta is equal to 2 mu plus mu upon 2 mu minus mu, that is 3 mu upon mu, that is 3. So we get f1 upon f2 is equal to 3. So this is the answer, and therefore the option 3 is correct. हेलो बच्चों, क्या हाल चाल। उम्मीद है आप सब लोग अच्छे होंगे, मैं भी अच्छा हूँ। इस वीडियो में हम लोग प्रॉब्लम सॉल्व करेंगे फिजिक्स से रिलेटेड, और वो प्रॉब्लम जो है हमारे लास्ट ईयर्स IIT मेंस में आ चुका है। तो चलिए वीडियो शुरू करते हैं। माई सेल्फ वीरेंद्र कुमार एंड यू आर वाचिंग हियर कॉस्मोस। तो प्रॉब्लम इज दिस: द मिनिमम फोर्स required to start pushing a body up a rough inclined plane, friction coefficient for the plane is mu, and that is F1, while the minimum force needed to prevent it from sliding down is F2. So if the inclined plane makes an angle theta from the horizontal such that tan theta is equal to 2 mu, then the ratio f1 upon f2 is. So बच्चों, you are given that there is an inclined plane that is making angle theta with the horizontal, and a body is pushed up by applying the minimum force that is equal to f1, and the inclined plane is rough, having the friction coefficient mu. But when the body is sliding down automatically, then the minimum force required to prevent it from sliding is F2. So in the both cases you have to find the ratio of the two forces F1 and F2. So let's solve this problem. So basically what you have, there is an inclined plane that is making angle with the horizontal theta. So this is the plane, and a body, suppose this is a body kept on this inclined plane and its mass is m, then the downward force acting on the body due to the gravitational attraction, that is acceleration due to gravity, is mg, and another force acting on the body is the normal reaction, that is applying the inclined plane on the body. And if we resolve this, and that is the n, if we resolve this mg into the horizontal and vertical components, then this will be this angle will be 90 minus theta, then this will be mg cos theta, and horizontal component of mg will be mg sin theta, right? And coefficient of friction on this plane is mu. So by definition, n is equal to mg cos theta, normal reaction is equal to mg cos theta, because this normal reaction is balanced by the mg cos theta component. And friction force, since this friction is always, because this see, this is the inclined plane. In the first case, see, in the first case, when body is being pushed up, body is being pushed up, when you are pushing up the body, the friction will opposite its motion. So then in that case, friction will be along the plane but in the downward side, and you are applying the force in the upward side. So the F1 is the minimum force that is required to push up. So F1 you are applying, F1 you are applying in the upward direction and friction is opposing it. So F1 is equal to, and this mg sin theta is downward, so mg sin theta plus frictional force. So this will be F1 is equal to mg sin theta plus F, because you are applying this force F1 in this direction and friction is acting in this direction and mg sin theta is also acting in this direction. So F1 is balanced by the mg sin theta plus F. This is the first equation. Now when body is sliding, naturally when body is sliding, naturally in that case, so when the body is sliding, then force F2 is acting downward. So F2, and when body is sliding, the friction force will try to stop this body, so that will act in the upward direction. So F2 is equal to this F2 is this body is sliding and you are trying to push, prevent it from sliding. So then you are also applying the force F2 in the upward direction because you want to stop this from sliding. So just F2 is in the upward direction along the plane. So F2 is equal to mg sin theta, F2 is equal to mg sin theta, and friction, your friction is along the, you are pulling this, and friction, when you are pulling, then friction will be in the opposite direction. Friction will be, because body is sliding and you want to stop it, body is sliding, then the friction will be opposing it. So mg sin theta minus F. So this is equation 2. You can say that F2 plus F is equal to mg sin theta. In other words, you can say that F2 plus F, because when the body is sliding, the two forces, friction as well as the preventing force, is acting in the same direction. They are trying to stop it, right? And the sliding is due to the weight acting along the plane, in the inclined plane, mg sin theta. So this is the two equations where F is equal to mu n and mu n is equal to mg cos theta. So putting this value F is equal to mu g cos theta and dividing F1 and F2, then we get F1 upon F2 is equal to, see, mg sin theta plus F, mg sin theta minus F. mg sin theta plus F upon mg sin theta minus F, but F is equal to mu g cos theta, mu mg cos theta. So that means mg sin theta plus mu mg cos theta upon mg sin theta minus mu mg cos theta. Mu mg is common, so mg is common, So that will be cancelled up from numerator and denominator. So that sin theta plus mu cos theta upon sin theta minus mu cos theta. So dividing, so what you are given tan theta is equal to 2 mu. You are given tan theta is equal to 2 mu. See, in the question it is given tan theta is equal to 2 mu. So we will use that one. So tan theta means dividing both sides, numerator and denominator by cos theta, you will get tan theta. Tan theta plus mu upon tan theta minus mu. Tan theta is equal to 2 mu plus mu upon 2 mu minus mu. That is 3 mu upon mu. That is 3. So we get F1 upon F2 is equal to 3. So this is the answer, and therefore the option 3 is correct. So bachcho, this is the solution for the given problem, and this problem is asked in 2011 in the All India Engineering Entrance exam, and I hope that you understand this solution and how to perform the solution, and the concept behind this problem is the resolving of the forces in the vertical and horizontal component as well as the normal reaction. So basic concepts behind this problem is to understand this diagram. If you understand this diagram and you understand also the forces acting on the body, you can solve the problem very easily. So I hope that it is clear to you.